Session 2, in which I'm going to cover the theory of practical teaching before looking at some of the specific practical skills and how you can teach them across the course. Now, the Marine Science A-Level now has a series of core practicals or required practicals that the students are expected to have a really good understanding of. But in addition to that, you can always do your own practicals to aid your learning. I wouldn't stick specifically just to those core practicals. Each practical that you do, whether it's a required practical or an additional one, is an opportunity to teach a variety of different skills to your students. And this session is going to look at how you can teach those skills across the course, but also within individual lessons. Now, to do that, I'm going to talk in 5 brief sections. The first is I'm just going to overview the practicals that are in AS and A2, before looking at how you can approach teaching an individual practical within a lesson and how to maximise the learning. Before expanding that to look at teaching practical skills across the whole of the course, a more holistic approach. Then moving on to specific details of the practical skills, before finally looking at mapping your teaching across the course so that you can build these skills in a constructive way. Now, the syllabus requires a series of required practicals. In AS, there are 4 laboratory-based practicals in units 1, 3 and 4. And I think these are really quite nice, easy practicals as a kind of introduction for your students to practical skills. Where AS gets a bit harder, I believe, is in the field-based practicals, which require transects, quadrats and mark release recapture. These are definitely a step up, but they are following the same rules as the laboratory-based practicals. So if you can establish good practice in the laboratory, taking it out into the field really shouldn't offer a challenge to your students. Moving on to A2, there are 9 required practicals in units 5, 6, 7 and 9. And these again are a step up from the AS practicals, but if you've established good practical skills in your students, then these shouldn't be challenging for them. So it should just be the natural, logical progression upwards. Now, the Cambridge University Press has a series of books that will massively aid you in your teaching of these practicals. The first is the course book, which can be invaluable to both you and your students. For each one of the required practicals, they have a section devoted to it, which covers an overview of the practical, covering a bit of the science and the theory, before an equipment list, a method, and then a series of questions that guide them towards setting up results tables, graphs, and exploring what the results might actually mean in terms of interpreting the science. To help you, there is also the teacher's guide, and this has, for each practical, a section which covers the theory and the science behind it, but also sections on setting up the practical and being prepared, common misconceptions or mistakes or areas where the students struggle, and then lots of help with questions that you might want to ask the students to delve into their understanding. Of particular use is also a table of results of exemplar data, where if the practical has perhaps not worked or you're not sure, these are the results that you would like to have got. So that's an incredibly useful resource. Okay, so how would you teach practical in an individual lesson? Now, as far as I'm concerned, I think there's 2 main approaches to teaching practicals. There is the inquiry-based approach or the skills-based approach. Now, I want to emphasise that neither of these is wrong, but it's important to kind of agree which way you're going to go with a practical before you start planning it. An inquiry-based practical is one where the students do not know the science behind it. So if you're teaching a topic over perhaps 3 or 4 lessons, this would probably be the first lesson, where they do the practical and they get to the results, and then you use those results to help teach the science behind it. A skills-based approach is one where the students probably know the science already. So perhaps this would be your 3rd or 4th lesson in teaching this topic. They know the science, and before the practical even starts, they've got a reasonably good idea of what the results would be, or at least the trend of the results. Now, as I say, there's advantages to both of these. My personal preference would be to do the skills-based approach more often than the inquiry. The reason for that, I find, is in an inquiry-based approach, you are asking an awful lot of the students. You're expecting them to learn the science behind the practical as well as the practical skills, and that can be a huge amount for them to take on. In addition to that, if you're going to use the results to help teach you the science, you need to be very confident that the results you are going to get will help. And particularly biology-based practicals, or maybe if your students are new to practical skills, the results are going to be unreliable or might well be unreliable. And therefore, teaching the science based on those can get very complicated. So while there is room for inquiry-based approach, I prefer a skills-based approach. You can use the practical to emphasize the science, but the students, because they already know it, can focus all of their attention on the practical skills. Now, across the year, definitely for the required practicals, I would always take the skills-based approach. It's so important for the students to understand these practicals that doing an inquiry-based approach is going to probably give them too much. Some of your additional practicals, you might decide that the best approach would be to do an inquiry-based approach. It might change the sequence of the lessons, liven things up, and just make it a bit more interesting. It is entirely personal preference. I've just told you here what I prefer to do. That was how to teach an individual lesson. I'm going to expand that now to teaching across the whole of the course. Now, I think there's two things that students need to take away from every practical, and you need to plan each lesson so that they can get both of these things. The first, particularly for the required practicals, is the students need to know the equipment, they need to know the method, and they need to know the expected results. Now, the coursebook here is immensely useful because it outlines all of those things for the students, so they can use the coursebook while they are doing the practical, or maybe before or afterwards, to really emphasize those things are important for their learning. That's the specifics for each practical. But in addition to that, each practical can be used to build on a bigger picture of experimental design and general practical skills, because the same rules apply to every single practical. And if you can build your practical teaching to reinforce this, every practical you do reinforces some of these rules, then the students are going to learn these much more organically and much more conviction than if you did each practical individually. It should also be emphasised that these rules are the same for laboratory and field-based practicals. Although they are very different in many ways, the general rules will very much apply. I'm going to cover these rules in the next section. So it's important to teach, firstly, the specifics of the practical, but also when you're planning how to teach it, think about which practical skills you want to emphasise to the students and how you are going to use the practical to do that. Now, the coursebook has an entire chapter on practical skills, and I'd strongly recommend you read that chapter before you start teaching the course. That way it's going to help you to build your practical skill planning across the whole year, rather than teaching each practical individually. And that practical skills chapter will really help you see where you need to emphasise to the students what skills they need to learn. To really help, I find that I build a scaffolding sheet for my students at the beginning of the year, and I will give one sheet for every practical I do, and it will be the same format for every practical. Building this familiarity allows the students to recognise the important parts from each practical. So this will be simple things like, what is the independent variable? What are the control variables? Safety considerations. If in every practical you've got a scaffolded sheet where they have to fill these sections in, when they come to planning a practical, they will know what needs to be in there because they have done it so many times. A scaffolding sheet also allows a fair amount of flexibility, which you can very much use to your advantage. So for example, at the beginning of the year, you might have a lot of help on that sheet, and then over the course of the year, the guidance from the sheet drops off, as the students become more confident and more independent in their own practical skills. You might also decide that you maybe want to include an empty results table in your scaffolding sheet. This has the advantage of both modelling what a results table should look like, but also saves you 15-20 minutes of the students drawing out their own table if you feel the practical either doesn't have time for that or it's not the emphasis of that specific lesson. A scaffolding sheet can be used to save time and offer guidance to the students. You can also, if you're taking this to its extreme, have different scaffolding sheets within a lesson if you want to differentiate to your more able students, or maybe ones with language difficulties or anything. You can use a variety of different scaffolding sheets. Obviously that takes a considerable amount of planning, but it's a very strong teaching resource. Now, I can't give you a specific example of a sheet because I find that for every class that you teach, it's going to be different. But I would generally try and find that sheet designed for you at the beginning of the year and use the course books, use the practical skills chapter, the equipment lists to help build that. Right, moving on to the penultimate section, we're going to look at the specific skills that you can teach in each practical or across each practical. So these are the experimental design and the practical skills that every single practical should teach, and you should use each practical as an opportunity to emphasize this to the students. It's important also to think that when it comes to their exams, the students won't be doing a practical, they will be planning or analysing a practical. So these skills are important for them to learn outside of a practical environment or in addition to a practical environment, not just as part of the practical, because when it actually comes to it, they won't be doing the practical on which they're examined on. So, how are you going to do this? Two approaches. You can start simple in AS and then add more complexity in A2. I would, though, instead, from the very beginning, teach to A2 standard. The rules are very much the same. They're slightly harder in A2, but certainly not impossible for an AS student. And if you can establish those rules firmly in AS, it means that they will be there already for A2. To do it separately means you've got to teach it one way in AS and then add something extra on in A2, which just seems more complicated than necessary. The practical skills chapter in the book, again, is really good at showing which are AS skills and which are A2 skills, but you'll find that you can teach A2 skills to an AS class relatively easily. So, individual practicals, and I'm just going to list these here with a bit of guidance on each. So the first one will always be the independent variable. Get your students to identify what the independent variable is. If they don't understand this, they don't stand a chance of being able to analyse an experiment. They have to know what is being changed. After that, the dependent variable. Now, what is actually being measured? This can cause an immense amount of confusion for students, depending on the practical. Sometimes it's incredibly easy. So, for example, the practical in AS is the freezing temperature of water with different salt concentrations. What you are measuring there is quite simple. It is the freezing temperature of water. But other practicals are much harder for students to identify what the dependent variable is. And a good example here is from A2, where you are looking at the rate of photosynthesis based on the light intensity. Now, what the students are going to count and measure is the number of bubbles produced per unit time, per minute, for example. But what they often put as their dependent variable is rate of photosynthesis, but that isn't correct. What they are measuring is the number of bubbles. So this is where it can get confusing, because sometimes in a practical what you're measuring is quite clearly what you are measuring, but sometimes what you are measuring specifically is what you are actually counting, not what you are inferring from this data. So it's really important to emphasize that to your students. Moving on, control variables. I find this is the hardest thing for students to grasp and takes a lot of time to really explain why some things are control variables and some things are just written in the method. In addition to this, you've got the experimental control, which they have to contend with as well, and there can be confusion within the two. Always get your students to write at least 2 different control variables. It's always important to get 2. If they can do 2 in every practical, that means you are training them up to that standard, and that will be very useful to them. After that, a method. Now, I've been teaching practicals for a long time for students, and every practical I've ever given a student will always have a method in steps. Step 1, step 2, step 3. And yet invariably, if I ask a student to write me a method, I get a paragraph of kind of constant, and then when this has happened, do this, and then when that's happened, do this, this. And it's so hard to interpret. Technically, it's not wrong, but for some reason, students do not like to write in steps. It isn't natural to them. And you should really be emphasizing from the very first practical, if you're getting them to write a method, to do it in a series of logical, progressive steps. You can also include equipment lists, and a drawing of the practical is immensely useful here. Emphasize that drawing ability is not important at all, and if they are literally doing stick diagrams of the equipment, that is going to be good enough. If it's not quite clear what they are, then you can always label the equipment in your diagrams. In fact, that's probably a good idea anyway. But you can do 3 or 4 lines, not know what it is, but if you just label it as a beaker or as a funnel, it makes it perfectly clear. Reliability would be the next one. With this, I literally get my students to repeat the line, repeat 3 times, and take a mean average. And that will apply to every single practical they ever do. Has to be the mean average, can't just be the word average, because obviously there's different types. And it has to be 3 times. It can be 5, it can be 10, it can be more, but it has to be at least 3 times. A trap that a few students fall into here, and you have to be really careful, when they write a method, they write the method and then they say repeat twice. What they obviously mean is do the practical and then repeat it twice more, but if you actually read the words they write, it just makes it sound like they've repeated it twice. So just emphasize, repeat 3 times and take a mean average. On the scaffolding sheet that we talked about earlier, you could have that written down in your first few practicals just to really try and emphasize that to the students. Moving on, interpretation of the results. Now this very much ties into the dependent variable. Is the thing that you recorded saying something about the science, or is it a proxy measurement for something else? Again, going back to the photosynthesis one here, you are recording the number of bubbles in unit time, but what it means is the rate of photosynthesis. So the interpretation of results and the dependent variable are often very much hand in hand. Finally, safety. And this is very similar to the reliability one, where you just have to emphasize consistency within the students. Students here tend to fall into the trap of saying what the precaution is. So for example, wear goggles. But that is not good enough. They need to identify the risk and then identify the thing that's going to reduce the risk. So, acids are corrosive. Make sure you wear goggles. The rocky shore can be slippery. Make sure you wear suitable footwear. It's what is the hazard and what are you going to do to reduce it? And I often, in my scaffolding sheet, would have a table here. One column is hazard, the other column is reducing factor, to again emphasize that. And by the end of the year, I would have removed that table, trying to get the students to see that it has to be both of them. So, what I've talked about there is the independent variable, so it's 7 things. The independent variable, dependent variable, control variable, method, reliability, interpretation, and safety. IV, DV, CV, method, reliability, interpretation, and safety. Whenever I get my students to do a practical, I will get them to write those 7 things, IV, DV, CV, etc., up in the top or on the margin every single time. That means you are training them to look for these things in every single practical, and when they are writing it up, they should be able to tick them off. The theory here being that at the end of the year, when they come into their exam, the first thing they should do when presented with a situation where they need to write this is in the margin, write IV, CV, DV, etc., etc., so that they know they are covering every aspect of it. And you have covered all of these things in every practical you've done, emphasizing those consistent rules. they're the basics. In addition to that, there's lots of other things you can use practicals to teach. So for example, hypotheses, results tables, what to do with anomalies, sources of errors, interpreting results for conclusions. All of these, you can decide if the practical you are teaching is a good opportunity to teach that. I would never try and teach all of these things in one practical. It's just going to be too much. But choose which ones you want to use. And some practicals will be better suited than others. Or perhaps if you've taken a skills-based approach to your teaching, you might want to emphasize method and variables. If you've taken an inquiry-based approach, you might want to emphasize hypothesis and conclusion. It very much depends on what you think is best suited to your practicals. But that brings us nicely to the final section, which is mapping. Especially when term gets started and you're very busy, it's really easy to teach each practical individually. And even if you're making a kind of gesture towards these skills that you have to teach across each practical, by the end of the year, it's difficult to make sure that you have covered everything you need to do. So here, at the beginning of the year, I would always map these skills. And by that I mean construct a table where I detail every practical that I'm going to do, both the required practicals and the additional practicals. And then I would list all of the skills the students need to learn over the year. So variables, safety, hypothesis, graphs, etc., etc., etc. There's quite a few of them once you start to list them. I would then basically tick which skills I am going to teach in each practical. Now, that gives you a really nice whole year approach to developing these skills. It's important to be flexible. If students don't get the skills in the lessons you've allocated to them, you will have to extend it. But planning in advance definitely gives you that possibility to be more flexible. There's various approaches here, and neither is better or worse. It's down to you. You might decide that you're going to spend the next 4 practicals emphasizing results tables. Maybe that's at the beginning of the year. Or it might be that you decide every 4th practical you do over the year will be results tables. So you're spreading it across the year. Some skills you might want to emphasize early on in concentration. Others you might want to come back to and reinforce again and again and again. But by mapping these skills across the year, or 2 years if you're doing it across A2 as well, you will make sure that your students get a really good education in building these practical skills, and you will cover each one in sufficient detail. So that is how the theory of teaching practical skills and some of the specific skills. So I gave you a brief overview of the practicals that are required, how to approach teaching an individual practical before looking at the holistic approach of teaching practical skills across the course, details of specific practical skills that you want to include in each one, before finally how to map these skills across all of the practical